virtual reality. The ability to explore another world.
Headsets like HTC Vive, Oculus Rift, and PlayStation VR have brought these experiences to the comfort of your own home.
But for this project, we asked ourselves, what if we can make it better? What if we didn't reinvent virtual reality, but what if we made it so you could feel it better? Our answer?
Our answer?
Our answer?
The Victory Glove. What we're showing you today is our senior design project, the Victory Glove, which stands for Virtual Interface Control and Tactile Response Embedded Glove. The goal of our project is to provide accurate hand and finger tracking, which is used to enable tactile feedback on the glove.
The combination of those elements work together to help enhance the virtual reality experience.
The creation of our glove features hardware components, network communications, as well as firmware and software development, all of which we studied throughout our UAH career.
Conceptually, we began brainstorming about how we could provide tactile feedback with our glove. We felt that the most viable way to accomplish this was to utilize vibration motors.
So by embedding 22 of these motors, which are about 10 millimeters in diameter and 2 millimeters in thickness, into the fabric of the glove, it enabled us to provide tactile feedback on the inside and the outside of the hand.
In order to power these, a rechargeable lithium polymer battery was used in conjunction with an ESP32 microcontroller. To regulate the voltage and monitor the current being delivered to each motor, voltage regulators and NPN MOSFETs were used. For motor activation, the ESP32 microcontroller receives signals via Bluetooth from the virtual environment in the host PC.
Vibrating motors embedded in strategic locations throughout the glove, connected to our ESP32 microcontroller, which is currently programmed to turn on all the pins at once. So when I plug the battery in, we'll see a blue and a red light. When the red light comes on, all of the motors should vibrate.
So on the software side of things, we focused on a few main conceptual tasks. What we wanted to do was build an environment to test out our hardware, that is the Victory Glove. We wanted to be able to track the user's hand and finger movements while they were wearing the glove as well as without the glove on. And we wanted to be able to send a signal to the ESP32 microcontroller that's based on the collisions that occur between the tracked hand and objects in VR.
Leap Motion, an infrared sensor attached to the front of the Vive headset, tracks hand and finger movements that control the hand module within Unity.
Alright, so what you can see on the screen here is our test environment that's made in Unity. The Leap Motion sensor that's on the front of the Vive headset is tracking each of my hand movements, and Unity takes that tracking information and produces a hand model that is one-to-one with my hand movements.
In order to receive collisions coming from Unity, a Bluetooth connection is established between the host PC and the ESP32. When a collision occurs between a specific part of the hand in Unity, the corresponding signal is sent to the ESP32 through this Bluetooth connection.
Alright, so now I'm going to demonstrate the networking component of Victory Glove. Get that out of the way. So basically what's going to happen is when I touch using a specific part of my hand, the corresponding signal is going to be sent. You'll be able to see it in the terminal. So as you can see, those signals are being sent and the motor should be vibrating.
Combining each component results in a functioning glove accessory that provides tactile feedback through interactions within the virtual environment.
We're going to grab one of these balls and hopefully feel the motor vibrate. Ooh. And they are vibrating.
While the tactile feedback provided through the Victory Glove is what we envision for the scope of the semester, we believe that this project is just a stepping stone for Kainotopia.
The progress made with the Victory Glove can be used for the future development of more viable VR accessories, which is our team's true goal.
We appreciate everyone for taking the time to watch our presentation, and we especially want to extend a large thank you to HTC for supplying our group with a full Vive virtual reality set for the purposes of our project. So thank you.
Thank you.
Thank you.
Thank you, and we hope for your continued support in the future.